Module 5. Production of other minerals and materials with mercury impurities.
Let's take a look at the Excel spreadsheet for your inventory of mercury releases from the sector of production of other minerals and materials with mercury impurities. Open your Excel spreadsheet from your toolkit button below. You will work your inventory for this category source in tab 5.3, Other Min and plus Mat of your Excel spreadsheet. As you can see, the tab provides me with different lines for each subcategory of this source. You will find more detailed explanations about each source subcategory in the next lessons. You can work with your training modules and your Excel spreadsheet in parallel. In lessons that are specific for each subcategory, we provide you with the key information to complete your inventory for the subcategory. We also provide you, when relevant, with important examples and exercises on how to use your spreadsheet. As explained in the previous modules, you first need to indicate if the subcategory is present in your country. So here, for example, I add Y for yes, and in the next one I add N for no, or I might add a question mark in case I was not yet certain. Here in this column you can see the default input factor suggested in the toolkit reference report for this subcategory, which in most cases is an interval. Here it says enter input factor. The spreadsheet already provides you with the recommended the intermediate default input factor, but here you can actually decide to enter your own well-documented factor, or you can use the D factor as you choose. If you decide to substitute a default factor, make sure to read additional information in the relevant section of the toolkit reference report. We indicate for you those relevant sections in the training modules for each subcategory. In your inventory reporting, all use factors must be described and documented explicitly. This is very important. Once you enter the input factor, you can enter the activity rate data also. Then the spreadsheet will automatically calculate the mercury input here in this column. Yeah. Remember to always use the correct units indicated in the spreadsheet for the activity rate. You will notice that for this category of other minerals and materials, the suggested activity rate to be used is the weight of the material produced or the weight of raw material used. You need to keep this in mind when you are investigating to find activity rate data in your country. For cement production, data may be available in National Production Statistics. Consult the National Statistics Department or the Ministry of Industry. Otherwise, contact the company or resource persons in universities, institutes, etc. Should you not find company-specific data, the USGA's National Mineral Reports generally include annual production numbers for cement. These can be found on usgs.gov. Go to the USGS page and look for energy and minerals. Then go to the mineral resources and then to minerals information. Choose to see statistics by country. You can find PDF reports where you will have data per year. Whenever you use data from this type of website, add in your report a specific internet address as part of the detailed reference to the source from which you get the data. Remember to always check that data is provided in the right unit for your inventory. If not, you need to convert it with resources on the internet. The USGS website is very useful as a resource. However, if you can get reliable data on the amounts of cement produced in your country, this should be preferred as activity rate data. For pulp and paper production, contact the companies for information on their biomass consumption, principally wood. On this is reported in National Natural Resources Statistics. In addition to the default input factors, your spreadsheet also includes default output distribution factors for the different output pathways. You can also change these default factors if you wish so, but make sure you have reliable and well-documented data to do that. When you insert your calculated mercury input value in this column, with saying enter mercury input, the spreadsheet will use the chosen output distribution factors and automatically calculate here the mercury outputs to different pathways such as air, water, general waste, products in some cases, and sector-specific waste. So those are in fact your mercury releases results for each specific subcategory. Note that for some subcategories you also have differentiated process configurations here in this very column. For certain life cycle phases, you will need to calculate mercury releases within specific types of configuration. This is the case for the subcategory of cement production, where you need to differentiate if the production is done with or without co-incineration of waste, as this factor will influence the mercury releases. If any of the process configurations or life cycle phases suggested is not present in your country, just indicate N for no here for that specific configuration. We provide you, to the extent possible, with default input and output distribution factors for all relevant life cycle phases for each subcategory. So in this category there are certain life cycle phases that do not have default factors. You will need to establish local input and output distribution factors for those lines in order to get calculated releases. Remember to always follow the correct units indicated in the spreadsheet. Should you have input and output factor data for phases with no default factors, copy the formula in the closest adjacent cell in the column, this column, calculate mercury input, to get your mercury input calculated with the factors you have inserted here. So for this category, you also have differentiated output scenarios for one or more of the life cycle phases. So you need to use the calculated mercury input in your spreadsheet for the relevant life cycle phase and distribute it amongst the existing output scenarios for that phase. For example, if let's say I have a calculated activity rate of 1 million metric tons of cement produced each year, the spreadsheet gives me the calculated mercury input of 110 kilograms per year. I can report that 50 kilograms are input in plants with simple particle control, 25 kilograms are input in plants with very efficient mercury pollution control and filter dust recycling, and 35 kilograms are input in plants with no filters. The sum of my data inserted in this column should equal my total calculated mercury input. Then you'll have results of mercury releases via each one of those source output scenarios, and finally have a total sum of releases for the whole subcategory. If one or more of the output scenarios are in fact not existing in your countries, you can leave those cells empty simply. The spreadsheet includes default output distribution factors for each output scenario. You can substitute those default factors with local factors if you have reliable and well-documented data. Let's, as an example, say that I discussed with the two cement production companies in my country, let's call them A and B. Each provided me with the amount of cement produced per year, 2.2 million and 2.6 million metric tons respectively. Both of them produce cement with substantial co-incineration of waste. Company A has a simple particle control system, while Company B has electrostatic precipitators and dry scrubbers, which are abbreviated ESP plus DS. So you can see it. You can see it here in the spreadsheet. Therefore, I sum up the amounts produced by the two companies and insert the total here in the activity rate cell for cement production with co-incineration of waste. As the amount produced by Company A represents 46% of the amount produced nationally, I then enter equals 0.46 times, I do that, and then times this cell, which is the cell with the total calculated mercury input, here, under the output scenario for simple particle control. The rest I insert in the output scenario of efficient mercury pollution control, as it's called, as this percentage is representing the production from the Company B. So here I simply write in the cell equals this total minus this cell, which is the part we already calculated, and I get the result here. So I keep the default output distribution factors and I obtain my results. Let's, as an example, say that I discussed with 3 paper production companies in my country. We can call them A, B, and C. Each provided me with the amounts of biomass used as raw materials: 2.3 million, 3.4 million, and 1.7 million metric tons per year, respectively. All of them produce pulp, but only one of them, Company A, has particulate matter control on the flue gas outlets. The other 2 have no controls in place. I sum up the amounts of raw material in the 3 companies and insert the total here in the activity rate column. I obtain my calculated mercury input. As the amount produced by Company A is 31% of the whole amount produced nationally, I insert here equals 0.31 times this cell, that is the cell for the calculated mercury input, under the output scenario for PM control. The rest I insert in the output scenario on no filter, as this is the percentage representing the production by companies B and C. Here I use the formula equals the total mercury inputs in this cell minus the result we just had before, meaning that we have the rest. I keep the default output distribution factors and I obtain my results here.